So these three are the three ways of operating with powers that we've learned previously in the previous videos. I'm going to delete them for a moment to have more space. So today we're going to learn a new way of operating with powers and how that works. So we're going to learn the operation a to the power of divided by a to the power of n. How would we do that? Well, let's try an example first. Let's try a to the power of 4. Whoops. Let's try a to the power of 4 divided by a to the power of 2. So what is this equal to? This is in fact equal to, well, we know that a division sign is basically a fraction. So this is actually equal to a to the power of 4 over a to the power of 2. Could we simplify this further? Yes. Using the definition of a to the power of n, this is equal to a fraction with a times a times a times a divided by a times a. So what is this equal to? Well, we can simplify this fraction by cancelling the top and the bottom. So cancelling 2a's from the bottom and 2a's from the top, we cancel the 2a's from the bottom and then we cancel 2a's from the top. We get a times a divided by 1. So this is in fact just a squared. Okay, now let's try another example. Let's try a to the power of 5 divided by a to the power of 3. How would we do this? We would do it using the same way we did before. So first, we rewrite it as a fraction. So this is equal to, what is it equal to? This is equal to a fraction where the numerator is a to the 5 and the denominator is a to the 3. And then expanding this, we get a fraction with a times a times a times a times a divided by a times a times a. So now the same thing happens. A times a times a cancels with a times a times a. So this is actually equal to, the bottom bit cancels to become 1, and then 3a's are cancelled. So this becomes a times a over 1. So this is actually equal to a squared as well. So how could we generalize this to a to the power of m divided by a to the power of n? Well, we could do this. A to the power of m divided by a to the power of n is in fact equal to a fraction where a to the power of m is on the top and a to the power of n is in the bottom. So, and then this would become, so a, using what we did from before, the n of the a's would cancel from the bottom and the top. So how many a's would there be remaining at the top? There would be a to the power of m minus n remaining at the top to the power of m minus n. So this is what it is equal to. But this is only true if this is true. This is only true if m is larger than n. So what if n is larger than m? Well then, so if n is larger than m, then m a's would cancel and there would be no more a's at the numerator, and there would be n minus m a's in the denominator. So it would be equal to a fraction with 1 over a to the power of n minus m. And this.